Hi there! This video still concerns with the factor theorem, but here there's a twist. In our previous videos, we were able to identify whether the given binomial divisor is a factor of the dividend. So we used there the remainder theorem, and if the remainder is 0, automatically our divisor is a factor of the dividend according to the factor theorem. But here, this is one of the two videos which involves this concern. We have coefficients here expressed in k, but the catch here is we are now assuming that our divisor is really a factor of the dividend. That would mean the remainder when we divide the dividend f of x by g of x is always 0. And our goal here is no longer to identify whether our divisor is a factor or not, but more importantly, solving for k, which would make that true. Our given function here, we have f of x, okay? So we have two coefficients of k here. So we have k x cubed minus 17 x squared minus 4 k x plus 5. We are going to assume that this g of x here, being x minus 5, is really a factor of this. So the goal is to find the value of k. These two k here should have the same value. Okay? To do that, we are going to show that the remainder when this function is divided by g of x is 0 using the remainder theorem in this structure. Since we have this, we have c being equal to 5. We are going to substitute that c here. So we will have f of 5. Okay? So we have f of 5 here. The result should be the remainder. And since again we are assuming this to be a factor, that result here should be equal to 0. Let's start by substituting 5 to all the values of x, not k. So we have 5 cubed minus 17 times 5 squared minus 4 times 5, times k, 4k rather, times 5 plus 5 here. So let's take k as it is. We know that 125 times k, because 5 cubes is 125, minus 17 times 25, right? Minus, this is multiplication, so 20k, and you have plus 5. So you will have here 125. Let's try to multiply this. Of course, we know that 425 is 100, and we have here 475, right? Kindly check. 425 rather. 425. Because that's 16 times 25 is 400, and we have another value here of 25. Minus 20k, and you have here plus 5. This would mean that the entire expression of the remainder is, we have 125 minus 20 is 105k, minus, we have this 420. This is the remainder. Okay, again, this is the remainder if we are going to divide f of x by g of x, but it's still expressed in terms of k because we don't know what the value of this k are. Okay, but since we are assuming this divisor to be a factor of a dividend, this remainder expressed in terms of k should be equal to 0, because according to our factor theorem, this could only be a factor if the remainder is 0. So solving for this, we have 105k and then minus 420 equal to 0. So we'll have 105k, add both sides by 420, you will have positive 420 here. And when you divide both sides by 105, you will have a result here of 4. Because 420 divided by 105 is 4. This is the value of k which could satisfy the claim that x minus 5 is a factor of this. Of course, if we're going to use that here, the entire expression is 4x cubed minus 17x squared minus, take note this is multiplication, 16x plus 5. This is now the goal of this as we solve for k, which could make our binomial divisor a factor of our dividend. That's all for today. You're dismissed. And please do not forget to subscribe now.